Good afternoon. Today we're going to go through IXL Assignment ZZB, Probability of Simple Events. Probability is the chance that a particular outcome will occur. So if we have a coin toss, is it going to be heads or tails? And then that outcome, that is one of the possible results of that probability experiment. So if we toss a six-sided die, our possible outcomes are 1, 2, 3, 4, 5, or 6. When we're working with probability, there are three different ways that we can represent our answers. We can represent our answers as a fraction, as a decimal, or as a percent. When we're doing the IXL assignment today, you could have a variety of those pop up. When it comes to simple probability, which is our focus for today, there are two different types. We have experimental probability versus theoretical probability. Let's actually talk about the theoretical one first. So that's right here on the right side. Theoretical probability is based on what's expected to happen. So if we kind of think about science, if you make theories, it's what you expect to happen or what you expect happened. So when we come up with a theoretical probability, if we keep kind of working with that coin toss example, we have the number of favorable outcomes, that would be 1, and then over the total number of possible outcomes. So here we have the probability of flipping heads, you have a 1/2 chance. And here we have the probability of flipping tails, you also have a 1/2 chance. Now, experimental probability, that's over on the left here, that is found by actually doing the experiment and observing your outcomes. So experimental probability, you actually experiment, you actually do it. So because you are recording data, you're performing an experiment, your probability statement is set up by the number of times the event occurs divided by the total number of trials. So let's say you tossed a coin 10 times, head is recorded 7, and tail is 3. That means when we set up our probability statement for heads, you flipped heads 7 times out of the 10 that you flipped it, so a 7/10 chance. And then tails was 3/10 because you flipped tail 3 times out of 10. Notice that experimental probability and theoretical probability don't always match. Because when you do the experiment, it's probability, it's a chance, you never really know for sure what you're going to get. All right, let's head on over to IXL and get some practice in. All right, here we are on assignment ZZB, probability of simple events. So you flip a coin, what is the P probability that it's going to be heads? Write your answer as a percentage. Since no data was given, that means we are being asked for the theoretical probability. Well, when you flip a coin, as we've been talking about, there's 2 sides, which means you have a 1/2 chance, or as a percentage, 50% chance. Let me actually break that down real quick, because there's more than one way that you can turn, your fraction to a percentage. I usually go to a decimal first. So we know that there's a 1/2 chance. So one of the sides is heads. There's 2 possible options. It could be heads or tails. As a decimal, that is 5/10. And then as a percentage, that is 50%. Because remember, when you turn something into a percent from a decimal, you either multiply it by 100, which is the same thing as moving that decimal point over 2 places. So we have a 50% chance. You spin the spinner once. What is P6? So what is the probability of you landing on a 6? We are also finding theoretical probability here because we are just spinning it once, all right? You could look at it as experimental. Doesn't really matter in this case since it's just spun once. Well, we spin it and we have, if I look at my numbers, 6, 9, 8, and 7, there's only 1 chance for me to possibly land on a 6. And there are 1, 2, 3, 4 total sections. So there is a 1/4 chance that I will land on a 6. 1/4 as a decimal is 25 hundredths. 25 hundredths as a percent we move that decimal over 2 places, is a 25% chance. Emily's father has a large collection of ties. He has 18 ties and 4 of them are green. If Emily's father chose a tie at random, what is the probability the tie would be green? Write your answer as a fraction or a whole number. So this time we don't want a percent, we want a fraction. Okay. If I am setting up a probability statement as a fraction, remember the numerator is the possible number of outcomes over the total number of trials. So we have here 4 ties that are green, and I want to know what is the probability that the tie he pulls is green. So there are 4 chances that he is going to pick a green tie, and that is over the total number of options. Well, he has 18 total ties. Even though I have been told to keep my answer as a fraction, we always want to simplify our fraction. Well, what can we simplify this to be? We can divide both of them by 2. So 4 divided by 2 is 2. 18 divided by 2 is 9. So he has a 2/9 of a chance of pulling a green tie. You roll a 6-sided die. What is P4? Now remember, this is our shorthand. The P stands for probability, and then what's in parentheses is what we're trying to find the probability of. So we want to know what the probability of rolling a 4 is. Well, if I think about a 6-sided die, how many times does a 4 come up on that die? 1 time. So we only have 1 chance of rolling it. And if it's a 6-sided die, there are 6 possible outcomes. So we have a 1/6 chance. My directions want me to write it as a fraction, and I can't simplify, so we're good to go. Oops, put a period instead of fraction. All right, let's bump it up a notch. A food company conducted a survey asking a group of people what they ate for breakfast yesterday. Here we're doing experimental probability now because I see that I have data. We surveyed something, we did an experiment. What is the probability that a random selected person had hot cereal for breakfast? So we want to know the probability of somebody having hot cereal. When I look at my data, I see that 10 people selected hot cereal. Now, my denominator is the total number of people surveyed. We need to add all of our people up. So we have 20 people who ordered French toast, plus 10 people who ordered hot cereal, plus 12 people who ordered waffles, plus 8 who ordered cold cereal. That gives us a total of 50 people. So 50 people went to or completed that survey. So 10 out of 50 people picked hot cereal. But as always, we need to simplify our fraction. Well, we can reduce that by dividing by 10. 10 divided by 10 is 1. 50 divided by 10 is 5. So 1/5 of the people had hot cereal. A city has 16 radio stations, including 8 public radio stations. What is the probability that a randomly chosen radio station in this city is a public radio station? All right, a lot of words, gonna have to reread through that. So what are we trying to find the probability of? We want to know how many people are choosing public radio. That's the nice thing about the shorthand, is it tells me that right there. Well, 8 of the radio stations are public. How many total radio stations are there? 16. So we have an 8 out of a 16th chance, but we always need to simplify. 8 is a common factor. We can divide, reduce by 8, 1/2 chance. Let's bump it up one more time, and that will then be are actually that we'll go ahead and do this one. Never mind. All right, this one is a little bit different because if we look at what we're looking for, what our probability statement is we want to find factors of 9. Well, let's list out our factors of 9. Oh, lost my pencil there. Sorry, guys. So factors of 9. So factor is a number that multiplies to equal 9. So factors of 9, we have 1 times 9. Then we have 3 times 3. Anything else? Nope. So our factors of 9 are 1, 3, and 9. When I think about a 6-sided die, is there a number 1 on a 6-sided die? Yes, there is. So I have the chance of rolling that factor of 9. On a 6-sided die, is there a factor of 3? Or sorry, is 3 on there? Yes, it is. How about 9? Nope. So possibly I could roll 2 factors of 9. So 2 out of 6 total sides, that simplifies to be 1/3. So we have a 1/3 chance. There we go. All right, it's your guys' turn to try. I know that you can do it. Just make sure you read it very carefully and set up your probability fraction correctly. If you have any questions, feel free to send an email or, of course, come to a help session. Bye.